Rather than solve quadratic equations, we're going to graph and solve quadratic inequalities in this lesson. And we pretty much go about at least the first part the same way as we have graphing regular equations. I'm going to complete the square and get it in HK form. So I've got y greater than or equal to, then we're going to isolate the variable terms, bring that 5 outside, take half of 6, square it, end up with 9. Since I'm adding 9 to the interior, I must subtract 9 to keep the equation balanced. We've got y greater than or equal to the quantity of x plus 3 squared minus 4. So I go over to 3 in the negative direction and down 4. Put a dot, go parent function 0, 0, 1, 1, 2, 4. And then go ahead and graph that. Now I have to shade. And just like all of our other problems involving shading, I pick a sample point. I usually go 0, 0. So if I plug into this equation right here, point 0, 0, I have 0 is greater than or equal to 5. Is 0 greater than or equal to 5? No, that's a false statement, so my shading goes to the interior of the parabola. Now, what we're going to do next is we're going to solve this inequality. Now, if we were going to solve the equality, what we would do is we would take and go ahead and factor. So let's start off that way and factor into x minus h, x plus 3. So if this were an equality, we would say our values are negative 3 and positive 8. Now we also know that if these are solutions, they're also x-intercepts to our graph. So if I were to sketch a graph out, here's 8 and here's negative 3, and I know I have a positive a value and my y-intercept is around negative 24 on the graph, and I graph that, this graph would look something like this. Now, the premise of the question is to find all values, find all output values, such that when I plug in for x, my y value is greater than or equal to 0. So if I'm talking about a y value that's greater than or equal to 0, I want to know where this graph is above this x-axis right here, because then those y values are greater than or equal to 0. Well, this happens for all x values that are less than negative 3, and for all x values that are greater than positive 8, my y values are greater than 0. So in order to state this as a solution, I would say, well, this happens when x is less than or equal to negative 3, or when x is greater than or equal to 8. Now, that's a graphical representation of this solution. If I wanted to do this without graphing, I could say, all right, here are what we call our critical numbers. These are numbers at which the graph either touches or crosses the axis. Now, I want to find out what kind of y values I have when x is outside of negative 3, between negative 3 and 8, and greater than 8. So I'm going to pick some random x values in these regions. So I'm going to look at what is the y value, or f of negative 4. I'm going to look at what is the y value, or f of 0. And what is the y value of 9. Now, when I do this, all I really care about is whether I have a positive or a negative answer, because that will tell me if it's greater than or less than 0. So if I plug -4, I could plug it into this equation here, but I'm going to choose to plug it here because I can get quicker answers in terms of positives and negatives to do this. So notice, plug a -4 in, I get a negative multiplied by a negative, and that equals a positive. A positive is greater than 0. That's a good answer for me. If I plug a 0 in, I get a negative multiplied by a positive, which ends up being a negative. That's not a good value. When I plug a 9 in, I get a positive and a positive multiplied together, which is a positive, which is also a good value. And these values here describe my answer here. So once again, my answer is x is less than or equal to -3, or x is greater than or equal to 8. Now let's do this without graphing at all.
So in this problem, we look and say, well, what multiplies to 16 adds to -10. Not too difficult. We've got x minus 8, x minus 2, and that's going to be greater than or less than or equal to 0. So I have critical numbers of 2 and 8. Let's list those here. And now, in order to see which numbers are going to make the inequality less than or equal to 0, I need to test numbers to the left of 2, in between 2 and 8, and to the right of 8. So I'm going to test f of 0, f of 4, and f of 10. I'm just going to take and plug each of these into this factored equation and see if I get a positive or negative number. When I plug a 0 in, I get a negative multiplied by a negative, which is a positive. When I plug a 4 in, I get a negative multiplied by a positive, which is a negative. And then when I plug my 10 in, I get a positive multiplied by a positive, which is a positive. Once again, I'm looking for all numbers which make this inequality less than. So that is this guy right here, because all negatives are less than 0. So I state my answer as all numbers between 2 and 8. And I can include each one. If you look at a graph of this, once again, I know we said we weren't going to graph, but let's just peek. Here are my intercepts of 2 and 8. This is an upward opening parabola, or quadratic, whatever you want to call it. And if you look at where the y values are beneath the axis, they're in between 2 and 8.
Let's do another. Now in this case, I need to make sure I have a side at 0, and I like keeping my squared terms positive. So I'm going to say 5x squared minus 27x plus 10 is greater than 0. Notice this is just greater now, not greater than or equal to. But still, we're going to have to factor this. I'm going to use a 5-step method just so you guys can review. X squared minus 27x plus 50 is greater than 0. I factor that into x minus 25, x minus 2, but then I have to remember that I'm going to take and divide everything by that 5 again and get x minus 5, because that reduces, and this is 5x minus 2. Thus I get critical numbers of 5 and 2/5, and I'm going to check x values to the outside in between these values to see what kind of y's they yield. So I'll check f of 6, f of 1, and f of 0. At 0, I'm going to get a negative and a negative, which multiplies to a positive. When I plug a 1 in, I get a negative and a positive, which is a negative. And then finally at 6, I'll get a positive and a positive, which multiplies to a positive. Now in this problem, notice I'm looking for which x values give me y values greater than or equal to 0. So again, I'm looking for my positive answers. Therefore, I have x is less than 2/5 or x is greater than 5. One more example, similar type of problem. In this case, we've got 0 less than x squared minus 5x plus 3. The difference in this problem is that this term does not factor, and it's not set up real nice for completing the square because this term right here is odd, so I'm going to use a quadratic formula. I'll say x is equal to, in this case, 5 plus or minus the square root of 25 minus 4 times 1 times 3 all over 2. So I have 5 plus or minus the square root of 13 over 2. And this is going to get me a couple of decimal answers. I'm going to have to do this on my calculator. And for the positive part where I add, I get 4.3. Then for the negative, I'm going to get really about 0.7. So now what I'm going to do is use these as my critical numbers. And in this case, though, when I test these guys, I have 0.7 and about 4.3. Unfortunately, I'm going to probably have to take, if I'm going to show this algebraic test, and plug back into this original problem. So I'd have to go f of 0, f of, let's go 1, and f of 5. So in this case, I would get the answer of 3. Which is positive. When I plug in 1, I get 1 minus 5, which is negative 4, plus 3, which is negative 1, and that's negative. And I plug in a 5, and I get 25 minus 25 plus 3, which equals a positive 3, and that's positive. So therefore, if I want to know what x values give me y values that are greater than 0, those are numbers that are less than 0.7 or numbers that are greater than 4.3. And if we look once again at the graph of this, here's 0.7, here's 4.3. It's a parabola that has an a term that's positive, therefore it goes up. And that totally makes sense relative to our graph. That's all we've got. Make sure you do your Ed Connect, fill out your survey. We'll see you tomorrow.